Hi everyone. We're going to go over 2017 AB4, and this was nicknamed the potato problem. The potato problem, and it says the following. At time t equals 0, a boiled potato is taken from the pot on a stove and left to cool in the kitchen. The internal temperature of the potato is 91 degrees Celsius at time 0, and the internal temperature of the potato is always greater than 27 degrees Celsius for the time greater than 0. The internal temperature of the potato at time t minutes can be modeled by this function h that satisfies this differential equation, where h of t is measured in degrees Celsius and h of 0 is 91. Now, what was misleading about this problem is that as soon as students saw that differential equation, they started to solve it. But it turns out we do not solve that differential equation. We solve another one later. So don't do anything until you read the question that says solve. All right. So part A says, write an equation for the line tangent to the graph of h at 0 times 0. Use this equation to approximate the internal temperature of the potato at time t equals 3. So now they will ask us to write the equation of a tangent line for sure. So what we have to do is we have to find the derivative of h when t equals 0. But when t equals 0, by this initial condition, h is 91. And it's strange, but the derivative function does not have a t in it. It just has it in terms of h. So we just substitute 91 for h, and the answer comes out to be negative 16. Okay, but the equation of the tangent line in point-slope form, well, this is the point, this is the slope, and at t equals 0 would be y, well, instead of y, we're going to put h. h minus 91 equals the slope times x, which is t, minus 0. So if we add 91 on each side, which we don't have to, but I will because it tells us to use the tangent line to approximate the temperature of the potato at 3. So h of 3 is about equal to negative 16 times 3 plus 91, and that answer will be 43 degrees Celsius. That's the approximation. And this is the tangent line. So this was a two-part question. 3 points for this part. 1 point for the slope. 1 point for the tangent line. And 1 point for the approximation. Okay. Now part B says, use the second derivative of h with respect to time to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time 3. So remember, whenever we find the sign of the second derivative of a function, what characteristic does that say about the function? It tells us about the concavity. So when the second derivative is positive, our graph for h is concave up. If the second derivative is negative, the graph of h is concave down. So first we have to get the second derivative. Now, the second derivative is the derivative of the first derivative. So we're going to differentiate with respect to time this expression. Now, here, because we only have one variable, right, I could factor out the negative a quarter, differentiate the h with respect to time, which is dh dt, and the derivative of negative 27 is 0. But we substitute dh dt back. So I get negative a quarter, which was carried down because we factor out the coefficient of a function when we find the derivative. And we substitute dh dt back. So we get negative a quarter, h minus 27. So that gives us 1/16 times h minus 27. And please note, this that I've underlined here, for time greater than 0, h will be greater than 27 degrees. It will never go below 27 degrees. It will be greater than 27 degrees. So the second derivative at time 3, and t equals 3, is greater than 0. So if that's the case, this is positive, and this is positive. So the second derivative will be positive at t equals 3. So this means that h must be concave up. And if h is concave up, and if we draw a little picture here, for a concave up function, the tangent line would be an underestimate. So we say then that the answer in B is an underestimate. So remember, for overestimations or underestimations of a function, we always look at the sign of the second derivative at the point in question. Okay, let's move on to part C. Part C says that when T is less than 10, there's an alternate model for the internal temperature of the potato at time t minutes, and it's a function of G that satisfies this differential equation. dg dt is equal to the negation of G minus 27 to the 2/3, where G of t is a function, but instead of G of t, we write G. G of t is a function measured in degrees Celsius, and G of 0 is 91. Okay, so T is in Celsius. Well, oh, I'm sorry. T is in minutes, and G is in degrees Celsius. Okay. Find an expression for G of t. Okay, so we have to find the expression for G of t, and based on this model, what is the internal temperature of the potato at time 3? Okay, so to find G of t, an expression for G of t, we have to isolate G, okay, because G of t is G. It's like the equivalent of solving for y. So we cross multiply again. And we have to separate the variables. Now, again, I could think of this as a -1. So we will divide both sides by the expression with G in it, but we will keep the numbers where they fall. So the -1 will stay with the dt, and what we're going to do is we're going to divide each side by G minus 27 to the 2/3. Okay, and now we're ready to integrate each side, but let's just rewrite this. So when we separate the variables, we get G minus 27 to the 2, dg over G minus 27 to the 2/3 equals -1 dt. Now we're ready to integrate each side. Okay, in fact, I want to put this in green because we added it. Okay, now we'll rewrite the left side as G minus 27 to the negative 2/3. Whenever we have a quotient in the integrand, we could always bring that denominator back to the numerator by negating the exponent. And this side is just negative 1 dt. Now, this is an easier integral. The integral of negative 1 with respect to t is t, and we said we'll add c on the t or x side. To integrate this using our shortcut with u substitution, and u is a linear function, the integral of u to the negative 2/3 would be u to the 1/3 times 3, because we add 3/3 to the exponent and we divide by that new exponent. So we could write this as 3g minus 27 to the 1/3. Okay, and the coefficient of the g here is 1, so the reciprocal of 1 is just 1, so that doesn't change. Okay, now we'll find c. And to find c, we have to substitute. When t is 0, g is 91. So let's substitute. We get 3 times 91 minus 27 to the 1/3 equals 0 plus c. And this comes out to be 64 to the 1/3 times 3 equals c. The cubed root of 64 is 4, so c is 12. So our function now becomes 3 times g minus 27 to the 1/3 equals t plus 12. But we're not done yet. Now here comes the algebra. We have to solve for the g. So we're going to get rid of this 3 by dividing everything by 3. So we get g minus 27 to the 1/3 equals t over 3 plus 4, which is 12 divided by 3. Then, to get rid of this exponent of 1/3, we'll raise each side to the reciprocal power, which is to the 3rd. And it has to be the entire right side and the entire left side. So we get g minus 27, since 1/3 times 3 is 1, and the rule when we have a power to a power is we multiply the exponents, equals t over 3 plus 4 cubed. Now do not cube this. Leave it that way. Our goal is just to isolate g. So we add 27 on each side. Oh, mistake there. I don't know if I could erase this now. I'm going to erase the whole thing probably. Okay, let's try it again. T over 3 plus 4 cubed plus 27. And that is our function g, which is also known as g of t, but we write g to make the notation faster. Okay, but it did say to find the internal temperature of the potato at time 3 based on this model. So g of 3, okay, so it's two parts, is equal to 3 over 3 plus 4 cubed plus 27. That gives us, oh, wait a second. I think I did something wrong here. Oh, no, it's correct. So 3 over 3, I just want to make sure that I got this right. 3, oh, what? Wait. I think I did a mistake here. Going back to the antiderivative, this should have been a negative t. That was my mistake. And if we substituted 0 here, it didn't affect the answer, but this is affected. So I have to put a negative there. I apologize for that error. And now when t is 3, this should be negative 3 over 3, which is negative 1. And negative 1 plus 4 is 3 cubed, which is 3 cubed plus 27. And that gives us an answer of 54 degrees centigrade. So I would have lost the point there because I forgot my negative, but I would have lost it once as long as I carried my arithmetic correctly. So please make sure you correct that. And this question, this particular question in part C, was worth, let's see, I have my rubric here, 5 points. 1 point to separate the variables. It was this over here, this step right here. That was worth a point. 1 point for the antiderivatives. That's where I would have lost my point. 1 point for the constant of integration, which is very important. And 1 point for the equation, and 1 point for g of 3. And in the second part, B, the whole thing in B was worth 1 point, which seemed a little bit unfair. It should have been worth at least 2 points, but it was just 1 point. And they gave the point for whether or not we have an underestimate or an overestimate. And if we did get the wrong second derivative, we immediately lost the point. Okay, so that takes care of this AP, the potato problem. I hope you found that helpful. Okay, take care now. Bye-bye.